Hello, everybody. This is Barb Stuckey, and I am coming to you from Mattson. We're very excited today to be talking about one of our newest toys that allows us to make amazing foods for our clients. So we've got a great lineup today, two people who have done lots and lots of extrusion work. And what we're going to be focusing on is extrusion, how it helps transform texture, expand portfolios, literally and figuratively, and create new occasions for consumers. So I'm going to introduce myself as well as the company. We'll try to get through that pretty quickly, and then I'll hand it over to my colleagues. So I am the Chief Innovation and Marketing Officer here at Mattson. We are a Silicon Valley-based innovation firm. We have 65 employee owners that represent a cross-functional team that ranges from strategists to scientists to scale-up specialists. We are driven by a passion for food and for making a difference in the world and our community through the work that we do for our clients. And our clients represent 100% share of stomach. That means that we work in pretty much every channel of food and beverage, from food service to retail to dietary supplements to ingredient companies, and we work across all different categories, from refrigerated to frozen, from food to beverage, and from fun to functional. We have some recent news, which is that we acquired a very kindred Chicago-based innovation firm that has now become Mattson in Chicago. And while our robust Bay Area headquarters food science cross-trained culinary team is still making magic on the products that we develop, in the acquisition, we would like to introduce to you our new chef operator team in Chicago. This gives us a whole new resource of creativity and inspiration for the projects that we do for our clients at the front end of innovation. And the thing we are most excited about right now is our Mattson AI. So we are using artificial intelligence across our business at almost every phase of development for our clients. That starts with insights. We use it for concept development and creative work in both our food studio as well as ProtoThink, which is a virtual ideation. We use it for optimizing concepts. And then we have Mattson Formulation AI, which is something we use internally to really optimize the products that we're developing. I'm going to start by talking about how we're thinking about some of the trends, which is really important to our business. This is a normal innovation journey from start to finish, and we help our clients with all the steps if they want us to, or a subset of whatever they need to achieve their goals. I'm going to go through that, and then we're going to talk about a piece of equipment. Let's be honest, this extruder that we have in our pilot plant. And so we'll start with what it does, and that's going to be my part here today. Extrusion really helps create unique textures, and those textures that are not often available through any other technique. The texture, we know from all of our research with consumers talking about prototypes, texture really drives signature flavor and liking. It also drives disliking. So it's really important to get the texture right. What we're noticing, though, is that we call it sensory evolution, meaning that texture is becoming more and more important to the experience that consumers have when they're eating foods and beverages. So while we've thought about taste and aroma for years, they tend to get all the glory. So it's really easy for consumers and other people to articulate the experience that they're having with taste and aroma. What is not so intuitive is texture. And so we believe it is the most underrated sense when it comes to the experience of food. That's why we're going to talk about it here today. There are so many products on the market, if you think about it, that have these really, really unique signature textures. Just think about the crunch of a corn nut and the sound it makes, the shatter that happens in your mouth when you eat it. Think about popping open that can of Pringles. There's the auditory sound that you hear, and then there's that unique crunch, the way that the saddle shape fits on your tongue. Of course, Hidden Valley Ranch is known for their smooth and silky texture that you can dip or pour or drench yourself in. And of course, on the left, cottage cheese is an example of a texture that's highly polarizing. So we know that that's the case as well. We also look beyond just the US when we're talking about trends. And one thing that we know is that in other cultures where they have very strong and very historied food cultures, they tend to use more specific food texture terminology. So if you look at this in the upper left-hand corner, the Chinese language has about 144 terms, not for texture, but specifically for food texture. And if you go to Japan, it has even more. So we know that texture is critically important, and we want to talk about ways to get to texture today. Now, this video isn't about an extruded product, but we love this video because it really shows that some brands do understand the value of texture and what it can bring to a product. So I'm going to play it, and hopefully the audio is working. Here we go.
Take a look at this heart. It's the one I'm gonna use to love you. Take a look at these arms. They're the arms I'm gonna use to hug you.
So as you can see, the brilliance of this Philadelphia ad is about the texture. It's talking about how you don't just taste something, you feel it. Okay, and now I'm going to talk a little bit about some case studies of how extrusion has transformed textures and created new consumer occasions. So this first one is an old favorite that we've already talked about, and that is Pringles. So Pringles has announced that they are abandoning the can for their newest snack. And Pringles are not extruded, but their new snack will be. It is a new consumer occasion that is a shareable occasion as opposed to the singular occasion that eating out of the can by yourself is. And it is a completely different texture that brings in different flavors and a different textural experience. So Mauricio Jenkins, who's the marketing lead for Pringles, says this puffy, airy snack not only gives fans a new way to experience Pringles, but its easy to share packaging creates a new way to enjoy their favorite snack with friends and family, whether munching at home for movie night or at a party or on the go. And our friends at Pop Chips went from popped to puffed. And we know these days that everyone is looking for clean ingredients. They are looking for real ingredients, whole ingredients. And this particular product was one of my favorites. And that is because it uses real peanut flour for protein and flavor. And then Pop Chips was able to give the product a coating of real peanut butter on the exterior of the chip, of the snack. So a really, really complex delivery of peanut flavor in a light and airy snack form. And you can see here just how clean that ingredient statement was. Peanut butter, peanuts, cane sugar and salt, yellow corn, and peanut flour. That's what consumers are looking for today. Things that they recognize, short ingredient statements, and deliciousness. And did you know that pasta is also extruded? And while if you look to the left, you might recognize these textures or these shapes of pasta, after so many years of cooking and eating pasta, they can become very boring. The thing is that innovation in the pasta space lately has really focused on nutrition, or sustainability. So here you can see examples of gluten-free pasta, protein-packed pasta, or using crops that are more sustainable than what we've used in the past. This new pasta was optimized for the eating experience, not for nutrition or sustainability. This is Cascatelli, which was Dan Pashman's journey to bring a brand new pasta shape to life. He had 3 criteria, which was forkability, meaning the pasta should be easy to pick up with a fork. So looking for functionality and texture. Sauceability, which means the pasta should hold the sauce well. And this is a concept called texture contrast. And tooth syncability, love that term, meaning that the pasta should have a satisfying texture when bitten into. You can buy this at your local grocery store these days or online. We are big fans of it. So I'm going to hand it off to you, Girish. Please introduce yourself, and we're very excited to hear what you have to say about extrusion.
Thank you. Thanks, Barbara, and thanks, Jamie, for inviting me to this webinar. Appreciate it. So quickly, just a brief introduction about myself. I'm a professor and an extension specialist at Washington State University in the School of Food Science program. And I do extension and research here at WSU. And basically through the extension program, we assist companies, any company, small, big, all sizes, all types, with respect to their processing and food safety areas. And on the research side, we focus on multiple things, but our main, I guess the core focus is extrusion processing. And if I go to the next slide, so here it talks a little bit about what we are focused on in extrusion processing. On the left side, as you see, we focus on a couple fundamental aspects. One of them is the expansion process, a direct expansion process that is very widely used in making a lot of the food products that you see on the market and what Barb just went through. And the other phenomena in extrusion is texturization, which is the protein texturization typically. So we also focus on protein texturization. Within that, there is two aspects. One is the low moisture and the other one is the high moisture. The low moisture made analog or TVP, in other words, some people refer to it as TVP. That we work on that as well as the high moisture meat analogs too. And in a new area of focus for us is taking that TVP structured proteins, plant proteins, and offering as a scaffolds for cell culture meat. So that's sort of our research area. And also one thing I forgot to say there, with the direct expansion process, where we have been researching on how best to incorporate higher levels of proteins and fibers without losing the texture or the expansion. And also we will focus on food ingredients, which is, especially non-traditional crops like the quinoa, buckwheat, millets, and pulses. And we try to understand the functionality of them once we fractionate and look at their different components. All right. Next slide here. This is simply a picture showing, the laboratory system that we have at WSU. And this is what a lot of my students and whoever comes and uses our machine, this is what they use it. It's a twin screw system. It's a clamshell twin screw Brabender system. And on the right side, you see the cooling die, which is typically what the industry uses for making a high moisture meat analog. All right. And this slide just gives you some examples of the products that you can make with extrusion processing. And at the bottom, you see all those colorful products. So those are the extruded direct expanded products, most of those, where you can get lots of different textures and shapes and sizes. Extrusion gives you that ability to make all these different products. And the left big expanded image, that's your high moisture meat analog, which has been ripped apart to see the fibers. And on the top, you see the TVP or the LMMA products. Next slide. So this here is a visual of how an extruder looks like. What you're looking at is a twin screw system on a production scale, and you can look at the product. It's a sheeted product that is coming out of the system, and you see all that steam that's in an extrusion is a high energy input processing system where a lot of mechanical energy is put in. And as the product comes out of the system, generally there's a steam that is generated, and that's what you see around that machine. Next slide. So this here is another picture of a production scale twin screw extrusion machine. What I would like to point out in this is on the top, you see that big barrel looking thing. That's a preconditioning system. In some instances, when we have to pre-cook the flours ahead of time a little bit, then we use a preconditioning systems. And at the bottom left side, that's your extruder barrel, and there is a die at the end of it. And also, I would like to point out that the motor is very important in an extruder because that limits your energy input. All right, next one. All right, so this this slide shows you sort of a dissection of an extruder, looking at what are some of the major components. Typically, an extrusion system includes screws, screw elements that are put together to form the screw profile or the screw. That's typically what we call a modulated screw profile. And then at the end, you see the die on the far right side. So, and if you look at the barrel sections, there are individual heating blocks around the barrels, and that helps us control the temperature. But in expanded products and also in texturized products, often the energy is generated, the heat is generated by the shear, which is through the mechanical energy that the screw imparts onto the flour, and a lot of the flour particles rub against each other, and that's what generates the heat. And you can see from moving from left side to the right side, the color at the bottom there shows blue to red. That basically signifies as the product goes from left to right, the product gets heated up. And due to that heat, there is a physical chemical transformation of the raw materials. And in a simple sense, we call them the starch melts, or the protein melts inside the system. And then it breaks down into different molecular weights, and that helps us to determine or impart a particular texture to the finished product. And in direct expanded products, what the typical conditions we see in an extruder is anywhere, barrel temperatures will be anywhere from 120 to 160 C. And the pressure, that is the pressure behind the die inside the machine, generally ranges from 200 to 1000 PSI, sometimes higher than that too, depending on the product, but that's the general range. And the moisture content for most direct expanded products will be anywhere from 15, they can go a little bit lower too, but generally 15 to about 25%. And one of the beautiful things about extrusion processing system is it's a very short time processing system where within 45 seconds or less, you can develop an expanded product. You put raw materials in the feeding port, and in less than 45 seconds, you get a product material at the end of the extruder. So it's a really unique system with a combination of a lot of different processing units or unit operations into one system. Next slide. So this is a quick video showing direct expansion as the product is coming out of the extruder, and this is on a lab scale system, and that's why there's only one die hole. On a bigger machine, you would have multiple die holes where you have a lot of product coming out. That's how you increase the throughput. But you can clearly see, if you really closely see at the end of the die, it's more translucent, and then as it goes towards the left, it is more opaque, and that's basically saying inside the machine, the starches melt form, and as it comes out of the system, it solidifies. Okay. Now, jumping into texturization of proteins, generally proteins texturize. general rule of thumb is you need to have at least 40% protein in the raw material to be able to develop some sort of a texture product. This can be categorized into two types of products. One is the low moisture mid analog or TVP, and that's what you see on the top figure or top image, and on the bottom side where you see the high moisture mid analog product. The difference between them is how we operate the die. The die in the TVP type product is a short die, typically looks like an expansion die. But for the high moisture mid analog, we need to take out all the air out of the system and compress the material and create layers so that it looks more like a muscle. And that's done by using a cooling die. So that is the major difference between these two. Now, going a little bit deeper into low moisture mid analog or TPP products, the extruder remains the same. What will change is the screw profile will change because you want to, depending on what protein and the level of protein you're extruding, you will need higher amounts of energy. So you'll have to change the screw profile for that. And the temperatures generally are in the same range. But the dies can be very similar, but in some cases, the die also needs to be changed to impart higher back pressure for it. And on the top right, you see the conditions, general conditions for a low moisture mid analog product is moisture content. As you see now, it's a little bit higher, 30 to 35%, plus or minus. Compared to expansion of starches, it was 15 to 25%. But the residence time is still very less inside the system. In less than a minute, you'll end up with the texturized product again. Now the difference here with the HMMA product is if you look at the moisture content, where I gave you the data up there, it ranges anywhere from 45 to 65% moisture content that you're inputting into the extruder. So there's a lot of moisture that goes in. And the residence time is greater than 2 minutes, and a lot of that is due to the residence time in the cooling die. And there is an image on this slide that shows you an example of a lab scale cooling die, where you see those tubes going in to the machine. That's basically going in the jacket, so that you cool the product as it's going through the die. That is a big difference. All right. Now, from a fundamental science perspective, what we understand today is when we extrude starches gelatize and degrade or break down in the general sense. Your granularity is gone, and then you get into these chains of starch molecules that realign in the die, and then you get it out of the system. It shapes into different products, cellular structure. So if the granules are not broken down, then you typically don't get the cellular structure. And also, it's important to know that when we extrude fibers, especially insoluble fibers, they don't change in the system, they don't melt, and they typically come out of the system as they are. So you really need to look at the physical attributes of the fibers when we consider extruding them or making a high fiber snack product. And the proteins denature, and they can be transformed into layered-like structures in the extruder. And that's simply because by adjusting the energy inputs and by having the right die designs for it. So all of these three major components or biopolymers, they all extrude differently. So if you're a product developer trying to use extrusion system to develop a product, you always need to consider the chemistry aspects of these polymers along with the machine aspects or the engineering aspects. So I just have a couple quick examples here to show you some research that was done in our group. In this one, you see the reference at the bottom if you want more information. We had a lot of work going on incorporating the upcycled products or ingredients into expanded products. So in this case, we were trying to incorporate cherry pumice, powdered dried cherry pumice into extruded snacks to see if we can incorporate, bring in a little bit higher level of fiber content. And in general, as you increase the fiber content, the expansion goes down. So, but at a lower levels of inclusion between 5 and 10%, you actually can enhance the product quality. In this figure, on the right side, you see the picture where you see from the white product that is basically cornstarch. And the first one you see on the right, that is with the 5% inclusion. So what we saw was the expansion actually slightly increases in that case and also makes the surface a little bit better, less shrinkage. But as you keep increasing the fiber content, then your expansion tends to go down. A solution to that is you can adjust the particle size, and that can help you incorporate a little more than 5%. And in our work, we have been able to show you can go up to 20% fiber, insoluble fiber incorporation by physically modifying the fiber. All right, I'll show you one more example here. And this one, just to demonstrate the capability of extrusion systems. Here you see whole bean flours. We used fava bean, pinto bean, lima bean, and kidney bean, red kidney bean, and as a whole grain flours and extruded them. Each one of them brings unique visual as well as textural attributes to it. So if you're a developer, product developer, you have all these different options to introduce unique textures to your product. And I'm just closing out my portion of the talk here to, always thank people who help do all this work. This picture shows you some of the students in the lab who have contributed significantly to a lot of projects we have done. But I'm always thrilled to see these kids go out and contribute to the industry, and I hope you get to hire these guys someday. Thank you. Now I'm going to pass it on to Jamie.
Thanks, Girish. That was great. Introduction into extrusion and the different types. So now I will introduce myself. So I'm Jamie Reeves. I'm the EVP of Product Development and Commercialization here at Mattson. And I get to talk to you about basically the next phase after the extruder. So really taking those transformed texture pieces and creating new consumer occasions that people want to eat versus just the dried pieces. So you can go to the next slide. So this is, I'm going to highlight a case study where we worked with JBS, which is a big meat manufacturer. So they wanted to get into the plant-based space. They were actually producing product in Brazil, and they found that it was formulated for the Brazil market that was not really in line with the U.S. consumer. So they sought Mattson's help to really transform the overly charred, different size piece things that they had to the U.S. liking. So we worked with texturized vegetable crumbles, which is very similar to what Girish just told you how to make them. And so the next stage when you would take these pieces is to hydrate them. So we evaluated many different flavors just to really build in that flavor profile that the consumer would want, the nice meaty notes. This application that I'm talking about was for an actual meatball, plant-based meatball. So our team worked on hydrating the crumbles, and also we wanted to mimic a real meatball. So we looked at actually grinding those texturized vegetable pieces into different sizes to really build in kind of that similarity to a real meat experience. Also, when you're building in your meatball, you want to build in functional ingredients that help bind the meatball or the patty together. So usually those entail methylcellulose to really build in that gel structure, as well as when you're cooking it, it gives you that cooking experience like you would experience when you're cooking meat. Also building in fat, if you want to mimic, really particulates that look like a solid fat that you would experience with meat. We build in coconut pieces or coconut fat pieces. So we really do build in all of those different elements that you would expect with a real meatball. So you can click one more time and it shows you a cut through to the actual finished product. So you can see, like I was talking about, we use those texturized pieces, ground them to different sizes. So you really get that eating experience that you would in a regular meatball, and you can visually see that. And we worked very closely with their team and actually helped them launch a new line in the US within 6 months, which is really rapid within this space. So you can go to the next slide. So this is just a quick video of our team at Mattson making the high extruded vegetable meat analog that Girish was talking about. You can click on the next slide. It shows a cutaway. So it may look funky because there's no texture in this piece, but if you click to the next box, you can see when you actually shred those logs, inside is really where you get that texture that really does mimic a meat experience, as Girish was talking about. So at Mattson, we always want to make something flavorful and delicious. So we worked with this client to really build in pork flavors and all of the attributes that you can go to the next slide that would season it and mimic a really wonderful, delicious street taco with shredded pork. You can show the next slide. So it really does bring it to life, really does help mimic that experience that a regular meat consumer would want to experience using the high moisture extrusion. So you go into the next slide. So the extruder is not only used for making meat analogs, we can make snacks and cereals. So we know a big trend, especially with Gen Z, is sustainability. And within that sustainability layer is upcycled ingredients. As Girish was talking about with his cherry pumice, consumers are really looking for ways to reduce food waste, as well as food companies are looking at ways to reduce food waste. And extrusion is one great tool that you can use to really transform that into something that's craveable and delicious. So just showcasing a couple products that are on the market that actually use the Upcycled Foods Association certification, which have to brag that Mattson helped be a founding supporter of that organization. So they are all about using upcycled ingredients and allowing companies that really do use ingredients that may have gone to landfills in their products and giving that certification. So we did not work with these clients or these companies, but just highlighting them here. So the first one is Spudsy, which they are basically rescuing sweet potatoes that would have gone to landfill, you're turning into dried powder, and then ultimately into an extruded puff snack, which then you can season in a multiple variety of ways. And then the second example is 7 Sundays, which is a oat protein-based cereal. So they are capturing waste from the oat milk production, which we know oat milk is very trendy these days. So there's a lot of this upcycled ingredient out there, and they're transforming it into a whole line of different cereals. They have chocolate and berry and original. So just a fun way to upcycle ingredients and make texture. So you can go to the next slide. So at Mattson, we have a 18 millimeter Leischwitz twin screw extruder. So what that means is we can help evaluate very small, we like to say like a handful of ingredients. So, you know, minimum 1 to 10 pounds, depends on what application and the amount that we're adding to our testing. So we've helped, this is an example of where we tested a novel protein So first, like Girish said, it's all about the functionality of the ingredients. So we perform a few benchtop testing of the protein or whatever that novel ingredient is to see how it's going to perform. So here's just pictures of sinkability, dispersion, water holding capacity. We have a whole battery of testing. This is just a few of them. So that's step one. Step two will be actually going to the extruder. So you can click on the next picture. And it will show just a series of testing that we did within the extruder, different conditions, temperatures, screw speeds, really just to dial in the right conditions within the extruder to get a product that we want for the color, the texture. In this application, we were making protein crisps that then in step three, which you can show the next picture, we actually put those crisps into a bar and got to evaluate it. So that's the unique part about working with Mattson is we can go from the dried powder, make something in our extruder, and then go into our lab and turn those ingredients into real product that we can test with our panel at Mattson or bring in consumers and get their feedback. We've helped our clients help refine ingredients over the years, doing different application testing. So it's a really just, we're integrated throughout. So we can help our clients really develop their ingredients and the right product for the market. So you can go to the next slide. So again, these products we did not develop, but they're just awesome examples of what's out there. Everything from fun crisps, the Harvest Snaps, and Cheetos, one of my favorites, and plant-based meat space with Impossible ground beef and Beyond chicken tenders. So extrusion can really just help your ingredient come to life in a multitude of forms. And if you need help bringing your ingredient to life or your product to life, please reach out to us at Mattson. We are certainly happy to help you discover your novel protein or ingredient superpower, or just create a new novel texturized product for you. Thank you.